Welcome to Mr. Math Academy. Grow your math brain.
Hello friends, welcome back to Mr. Math Academy. So today in this video we discuss the product rule in a differentiation. In the previous videos we have done the basic introduction about the differentiation, some numericals which is related to the addition and subtraction, and we have given so many like a list of formulas we have given. Now let us move on to the what is the product rule, how we can able to apply this product rule when the given function is in terms of the multiplication. Because when the two function is given with respect to the like a product in terms of the multiplication, so what will be the sequence, how we have to apply the product rule so that we can get the solution here. Okay, now let us move on to this product rule here. Let us consider if I take f of x is equal to, so two function is if I give in terms of the u into v, where u is nothing but one function and v is also one function. So he has given in terms of the product here u into v. So the next thing is what we just differentiate this. So differentiate the given function, differentiate with respect to x. So what we can get here is, so this becomes f dash of x. Now here the thing is what we just remember that. So first thing is when we differentiate this with respect to x, the first term will just keep as it is. The second thing is, so after writing this first function as it is, we have to differentiate the second, and again plus we have to keep the second function as it is, and again we have to differentiate the first one. Means what? I'll just keep the first function as it is here. Now I'll differentiate the d by dx of the second function, that is a v. So plus second function I'll keep as it is, that is v. Now I'll differentiate the first function with respect to x, that is the d by dx of u. Okay, this is the basic formula, this is the basic method when we are solving the problem with respect to the product rule here. Okay, this is when the two terms is given. So I just take the f of x is equal to u into v. So differentiate this with respect to x. So this becomes f dash of x. So now this is our first function. I'll just take this is a v is a second function. So what I'll do, I'll just take this first function as it is and differentiate this v with respect to x, that is a differentiation of the second function plus second function into differentiation of the first function. Similarly, so if I give some three functions like f of x is equal to, if I give u into v into w, three function is given in terms of the product. So how we can able to differentiate this means, so what is the differentiate of this function? So differentiate this, that is with respect to x. So we can get f dash of x is equal to, so this is the first function, second function and the third function. We just keep this first second function as it is. Now I am differentiating the third function, that is the d by dx of w, plus I'll just take the second one, that is the second and third as it is, that is v into w. Now I'll differentiate the remaining first term here, that is u, plus I just take the third term like a w into u as it is. Now I'll differentiate the d by dx of v. Now this is how we can take the functions when the three term is given. Similarly we can go for the four terms. Okay, now we just take some examples here. So if I take example 1, that is the y is equal to e power x into sin x. Now here you can just see there are two function is given, e power x and sin x is given. Okay, now what we have to do, we have to go for the product rule here. So differentiate this, differentiate the given function with respect to x. So this becomes dy by dx here. So that is equal to, so I'll just take this e power x as first function, the sin x as a second function. I'll just keep the first function as it is. Now the second thing is I'll just take the d by dx of sin x plus second function I'll keep as it is and d by dx of first function, that is e power x. This how we can write here. So this become our y dash. So e power x. Now we know that d by dx of sin x is cos x, because the differentiation of the sin x is cos function. You can take the sin sin of any function, you can take the d by dx of sin x is cos x here. Similarly, this sin x I'll keep as it is here. We are not differentiating for this term. Now we are differentiating this d by dx of e power x, that gives the e power x as it is. So still one more step we can solve here. Just simplify here. E power x you can take the common. So this becomes cos x plus sin x, you can take in this form. Okay. Now we'll just take some more examples here. It's a quite simple. First function into differentiation of second, second function into differentiation of the first. I'll take the y is equal to sin x into log x will take, for example, okay, like a trigonometric function, the logarithmic function. So differentiate this, differentiate with respect to x here. Now this becomes d by dx of y, that is equal to, again you can take d by dx of sin x into log x. So this is our first function. Now this is our second function. So the thing is, so this becomes y dash. I'll just take the first function as it is. Now d by dx of second function plus second function keep as it is. Take the d by dx of the first function, that is the sin x. Now you just simplify, you just take the differentiation of this. So this sin x is there. We know that the d by dx of log x is our 1 over x. Now the log x will be, we have to write as it is, the d by dx of sin x is our cos x. Okay. This is what this d by dx of the, that is the differentiation of the given function. We will just take one a few more numericals here, examples. Take y is equal to, I'll just take the x power 6 into, I'll just take the tan inverse x. So this is also, the two function is given. Now differentiate this, differentiate with respect to x. Now this becomes d by dx of y is equal to, so first initial we just write it in a standard format, x power 6 into tan inverse x. Now this becomes y dash on the left hand side. So this is our first function, second function. So first function I'll write as it is. Now the d by dx of the second function, that is a tan inverse x, plus second function is our tan inverse x. Now d by dx of x to the power 6. Okay. Now the thing is, this is our y dash is equal to x power 6 is there. So we know that the d by dx of tan inverse x is 1 over 1 plus x square. So this is our d by dx of the tan inverse x, plus the tan inverse x will be, we'll write as it is here. Now the d by dx of x power 6 is 6 into x power 5, that is 6 into x power 5 here. Now this is our, that is a simplification of the given function here. So similarly we can follow for the any kind of functions will be given in terms of the product here, either it may be for the three functions or 4 functions, whatever it is. We just have to follow the same procedure here, like for first function into d by dx of the second plus second function into d by dx of the first function. In the next video we will go for the what will be the quotient rule, that is a divisible rule here. Okay, if you like this video, please comment, share it to your friends and subscribe to our channel.